this first one that we're going to look at has a graph, and we have to write the function based on the graph. So give me a minute to get it all drawn, and then I'll label some stuff for you. Pi over 6, that's important. Got a pi over 2, that's important, and I'm just putting those on there, not actually measuring or counting or doing anything. Okay, this is going to be 1 here, that's important, and negative 1 here, that's important. Alright, so I'm going to go pi over 6, negative 1. Have a point there. Then we'll have a point at pi over 2 and 3. So there's 1, 2, 3. That'll be pi over 2 and 3. And 7 pi over 6 and 3. Alright, so it's going to go. Oh, that's not very good. I need to get that other point up there. It's really wet.
So there's not a point, another down low point?
Yeah, I just don't know what it is.
I was using.
Yeah, it's going to hit down there in the middle of them somewhere. Alright, so that would be 7 pi over 6 comma 3. Okay, I think that's about... Yeah, that's everything I've got there on that. So the directions say to write a function for the sinusoid. Remember that funny word? For the sinusoid shown. So that just means it's going to be the graph of a sine or a cosine. So we got to write f of x equals whatever. Okay, we did this. Got several steps to go through. Lots of things to find out of this. First thing I'm going to find, what is my max? How high does this graph go? 3. What's my min? Negative 1. So to find out if this has been scooted up or down any, I'm going to do max plus min divided by 2. So that's 2 divided by 2, which is 1. So that means this has a k value of 1. It's been scooted up 1. Okay, and that should be fairly obvious to you by looking at it. This x-axis is not in the middle, is it? It's the 1 that's in the middle. So that's how you know it's been scooted up 1. Okay. After that, we're going to figure out whether it should be a sine or a cosine graph. Okay, so remember, and this is where I always have to visualize, remember the whole thing has been scooted up 1. Okay, so if we can visualize taking this thing and scooting it back down 1, where would this point be? 0, 0. At the origin. And what kind of graph started at the origin? Sine. But what's different about this one? Well, when we move it down to here, normally they went up first. That one will be going down first, which means in the form y equals a sine bx, our a is going to be negative. Very good. So y'all are ahead of me on some of that stuff. All right, so we know it's sine. We know our a is going to be negative. Okay. Now we need to find the amplitude. Let's go ahead and find the amplitude because it's almost identical to your k. What was the major difference in finding the amplitude? Instead of an add, what did we do? Subtract. So we're going to do 3 minus negative 1 divided by 2. So 3 minus negative 1 is 4. 4 divided by 2 is 2. So that means we're looking at an amplitude of 2. But when we write it in our function, it's going to be a -2 because what y'all just said, it goes down first. All right, so only other thing, if we're trying to get this in the form, let me write it in a new color for you. If we're trying to get this in the form y equals a sine b of x, we know we know it's going to have a +1 stuck on the end. We know we're going to have a -2 in a spot. The only other thing we haven't found yet is the b. Okay, formula for finding period is 2 pi over b. I can get my period from looking at this graph. Remember, a period is what the distance of one cycle is. Okay, so pick yourself out one cycle on this. The way I did it when I was working it this morning. Remember, a cycle is a whole complete something, whatever you're dealing with. One cycle on your bicycle wheel means it goes one time around, whatever. So I always go from the tip of this mountain to the tip of that mountain. That would be one cycle because I went all the way down to the valley, got all the way back up to the top of the mountain. So I got to figure out how far that is. Well, this one's at pi over 2, and this one's at 7 pi over 6, right? How do you find the distance between 2 points? Subtract them. So I'm going to do, not going to worry about the pi's. I'm just going to look at the fractions. I'm going to do 7/6 minus 1/2. 7/6 from here, 1/2 from here. So I've got 7/6 minus 1/2. That's pretty easy when you type in your calculator if you want to, but that's a pretty easy one to do in your head because you know 1/2 is the same as 3/6. So 7/6 minus 3/6 is 4/6, which is 2/3. So now don't forget those pi's, which makes that 2 pi over 3, right? So the period is 2 pi over 3. Period is the same as 2 pi over b. So what's our b? 3. There you go. See, that means it has to be 2 pi on the top. 3 has to equal b on the bottom. So to write your function now, we had f of x equals, we talked about our a is negative, so negative, what was it? 2 sine of b x, and then what about that first thing we figured out? It wasn't centered, it was scooted up 1. That's it.
So it doesn't matter that they didn't tell you like where that other thing was.
As long as you can get one cycle out of it. Alright, this next, I don't remember the date of where it is in your notes, but this next stuff that we're going to look at is the trigonometric identities, when we had to verify the identities. We had to use all those rules and show how we went from something to something else. So you're going to need to flip back and find all those identities. There was the Pythagorean identity, cofunction identities. So flip back and find where that is, and whoever finds it first can shout a date for us. If you dated, if not, you want 3/15. If you date your notes, it was on 3/15. Okay. All right. While you're finding them, I'm going to write what the first one we're going to do is cotangent squared of theta over cosecant of theta. Is equal to cosecant of theta minus sine theta. Okay, so they tell us that, and they say to verify that. So we've got to take this part on the left side of the equal sign and go through as many of the properties as we can until we get it to look like this part on the right side. We have to show all the steps that are involved there. Okay? All right. Anybody? My thought process, I'm only looking at the piece on the left. That one on the right is where I want to end at. So I'm only looking at that piece I just put in the box. My thought process is that thing's got a squared on it. So I'm probably looking at the Pythagorean identities. Are you with me on that? Okay, now those all had 1s in them. Remember, all those Pythagorean identities had 1s in them, so we had to be able to rewrite them a little bit. What does the cotangent one say in the Pythagorean identities? 1 plus cotangent squared. Let me write it over here on the side. 1 plus cotangent squared equals cosecant squared. Okay, so I've got cotangent squared. So to get this Pythagorean identity solved for cotangent squared, all I would do would be to subtract 1 from both sides, right? So cotangent squared is the same as cosecant squared minus 1. Right? So I'm going to take cosecant squared minus 1 and I'm going to put it in for cotangent squared. So I'm going to write cosecant squared of theta minus 1 over cosecant of theta. Okay. Now this next step that we're going to take here is one that I get stuck on a lot just because I forget it. And I don't know why I forget it because I'm pretty good with fractions, but when you've got something being subtracted on the top, like if we had, you don't have to write this down, if I had 4 minus 3 over 1, that's the same as 4 over 1 minus 3 over 1, right? So that's what I'm going to do when I've got subtraction on top or addition and just one denominator. I'm going to rewrite it with 2 denominators. So I'm going to have cosecant squared theta over cosecant theta. Then I'm going to have minus 1 over cosecant theta. That means the same thing. Okay, now this right here where my mouse is, cosecant squared over cosecant, that can simplify. When you have something squared over the same thing to the first, can't you reduce that? Like, for example, if I had x squared over x, isn't that the same as just x? So if we got cosecant squared over cosecant, isn't that the same as just cosecant? Is that what you said there, Brooklyn? Good job. So that gets me cosecant, and then I still got minus 1 over cosecant of theta. Okay. Hey, we're to a subtraction problem, and I've got the first half of it right. Cosecant's right. So I probably don't want to change that. I wonder what about this thing here? Look at your reciprocal identities. What's 1 over cosecant the same as? Yeah? No? I was with you there for a second. 1 over cosecant. What's it the same as? So what you said, Gracie? Sine. Everybody find that? So? Do you need help, Brooklyn? I'll put an equals and I meant to put a minus. I'll show you a second. Let me get it. You bet your boots. Is that good or more?
No, I just need like
Alright. You found Macy helps you find it?
Yes.
Okay, that is what they told me to stop at. So I got that. That's the same thing. Connect those lines there. That's the same thing. So the work was all of these steps. That, out of all the trig stuff, that's probably my least favorite. Because I feel like, and this is just my poor attitude about it, but I feel like you've already told me what it simplifies to. Why do I got to go through the heartache of that? But I guess it makes us smarter, huh, Gracie?
Sure. Is there a lot of those on the desk?
I think there's like 3 or 4 of them.
How would you?
We'll do another. Friday. Free. Alright, everybody got caught up on that one? Good? Okay, let's try another one of those. Let's say we had cosine of x, secant of x over, we just used x's instead of thetas, means the same thing. 1 plus tangent squared of x, and then we want to stop when we get to cosine squared of x. Alright, everybody ready? You could potentially start somewhere other than where I start and still get the same deal. Those squareds and ones always grab my attention. So on that denominator, I'm looking at the Pythagorean identities there. Okay, so I've got Pythagorean identities that has a tangent squared in it, says 1 plus tangent squared is equal to secant squared. So that's exactly what that is, isn't it? So I'm just going to put secant squared in its spot. So that's going to give me cosine of x, secant of x over secant squared of x. Okay, now like before, we can reduce this one. Okay, this one they're not separated by a plus or minus sign, so I'm not going to rewrite it as two things like I did before, but I can reduce those secants, right? So the secant on the top is going to go away. It's just going to be cosine on the top, and then a secant to the first on the bottom. Okay. What about now? Any ideas on what we could look at now?
Secant is equal to 1 over cosine.
Okay, right here, that's going to be the key. Gracie found it, very good. Secant is equal to 1 over cosine. She got that from the reciprocal identities. So this is going to be cosine of x over 1 over cosine of x. Now that looks ugly, but I'm excited because I'm just one step away. When we divide by a fraction, that's the same as multiplying by the reciprocal, right? And so what's cosine times cosine? Cosine squared. Brooklyn's like, what are we doing? Is this magic? Good job, Gracie.
So you're not really figuring out anything. You're just
Right.
looking at.
Usually,
That's what I hate.
Me too. That's what I said on the last one. I said, Spline, this is my least favorite. I like to figure stuff out. I'm like you, man, in that respect. She said, Alright, ready to try something else? Alright, here, changing gears for a minute. Here I'm asked to find the exact value of the sine of 105 degrees. Exact value, that's key. Because first thing I'm going to do is I'm going to look at my unit circle for 105 degrees. Because remember, your ordered pair is cosine comma sine. But that's not on there. It goes from 90 to 120, I think. So 105 is not on there. Okay, then I'm like, well, can I make sure I'm in degree mode and hit sine of 105 on my calculator? Yes, but I can't use that because it's going to be an irrational number. It's going to keep going, and this says find the exact value, not a rounded answer. So I can't do that. Okay, so when we ran into this problem before spring break, when we had to do this, we rewrote these using the sum and difference formulas. And this was probably the day after those reciprocal identities in your notes, the sum and difference formulas. What I'm doing here is I'm taking 105 degrees and I'm looking on my unit circle for 2 degrees that I can use to make 105. Like what plus what is on my unit circle that adds to 105? Or what minus what is on my unit circle that adds to 105?
60 and 45.
Okay, 60 and 45, everybody find that. And there's sometimes more than one right pair, but Macy was quick on the 60 and 45, so I'm going to do that. So that means that this is the sine of, where I did that, there we go, sine of 60 degrees plus 45 degrees. So that's no rocket science there. We know that that makes the 105. We've just got it rewritten, ready to go. Okay, now the sum formula tells you, and this, you've got to remember this or have it in your notes there, the sum formula says I'm going to take the sine of 60 degrees times the sine of 45 degrees plus, hold on, that's cosine, isn't it? Yep, y'all got your formula out. This one is sine cosine, right?
Yeah.
Glad y'all got your formulas out. Thank you. Okay, then I'm going to add that to the cosine of 60 times the sine of 45. Okay, now you know those values for 60 and 45 from your unit circle. So I'm going to go to my unit circle now, and I'm finding 60 degrees. At 60 degrees, it gives me the ordered pair 1/2 and square root of 3 over 2. So that is the cosine and the sine. At 45 degrees, it gives me the ordered pair of square root of 2 over 2 and square root of 2 over 2. Remember, that's the cosine and the sine. So those are the values that I'm going to plug in. So sine of 60, find sine, square root of 3 over 2, times cosine of 45, find cosine, find 45, square root of 2 over 2, plus cosine of 60, 1/2, times sine of 45, square root of 2 over 2. Okay, so square root of 3 times the square root of 2, that's the square root of 6. 2 times 2 is 4. 1 times the square root of 2 is just the square root of 2. And 2 times 2 is 4. Now here's a very common mistake that a lot of people are going to make. They're going to say the square root of 6 plus the square root of 2 is 8. No. You can't add them unless they're the same underneath. So I'm just going to leave this as the square root of 6 plus the square root of 2 all over 4. That's your answer. Do I have those sum and difference formulas memorized? No. But I put them on took a picture of them and put them on the board for you and told you to put them in your notes. So you should have them there. They're not hard to use. And it's not hard to, I guess maybe I should memorize that. Sine, cosine, cosine, sine. That's not hard. I don't know.
So would you just type this in my calculator or no?
To check it, what I would do is I would go and I would type sine of 105 in my calculator, make sure I'm in degree mode, type sine of 105 in my calculator. She got like 0.966 about. Then I would go and I would type this in my calculator and I should get the same, close to the same thing. Yeah, she did. So that's a way you could check it. You need help with that?
Yeah.
Okay. Oh, sorry, I thought I kicked you. That'd be bad. Got a little cycle there on there.
Yeah, I bought my crocheted one and my phone.
That's cool.
How long will you do? Like one person? It's like a board on my calculator. I took those into there for like 14 days.
How many did you get?
7 days. Okay, so I was just enjoying my food. I like lunch on Saturday, just going through my Snapchat stories, and then I came across that. And I was like,
I know, me too.
yeah.
It was pretty cool.
I mean, it looked. I would have.
That was everybody in the dugout was either like, "Oh, that's so cool," or they were like throwing up.
Yeah, there was no in between.
Yeah, it was like dripping blood. It was so good. How metal could have gotten Oh my God. I went through a baby crying.
I did cry. Yeah, I cried.
All right, let's do one more. Sine of 75 degrees. All right, so look at your unit circle. Find something that's on two angles that are on our unit circle that we can use to make 75. 45 and 30. So I'm going to go with Kylie on that. It's going to be a sine of 45 degrees plus 30 degrees. Now remember, and I'm like y'all, I like addition as well, but you could do subtraction. There's a sum formula, there's a difference formula that you could use as well. Okay, but now I'm going to put what those ordered pair with that is. The 45 degree angle is that old square root of 2's over 2. So there's your cosine and sine. The 30 degree angle is square root of 3 over 2 and a half. Alright, so just like it's going to be the same as the last one here, I'm going to start off with the sine of 45 times the cosine of 30 plus the cosine of 45 times the sine of 30. Did I get it set up right? I tried to do that without looking. I was practicing my memorizing. Did I get it? Oh, good. Alright, so let's plug them in now. Remember, the first one is cosine, the second one is sine. So sine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Plus cosine of 45, square root of 2 over 2. And sine of 30 is a half. It's going to be pretty similar to the previous one, isn't it? Square root of 2 times square root of 3 is the square root of 6, and 2 times 2 is 4. Square root of 2 times 1 is the square root of 2, and 2 times 2 is 4. It's not similar, it's the same. Isn't that ironic? I always get scared though. Did I mess up? How do I get the same answer?
I put it in my calculator.
You checked it? Good. Macy checked.
Well, I just did the sine of 75 and you did the same thing.
Yeah. Cool, cool. Alright. Hope that's got your brains back going after spring break a little bit. Tomorrow I'm going to have the practice test or study guide or whatever y'all call it. I don't know. Everybody calls it something different. So we'll have that to start working on tomorrow. And then we'll go over it Thursday and do test Friday. Good?